video. It's going to be an amazing video. Yeah, I'm recording. Of course it was.
So what happened? My
I'm
rocket,
gonna send it to him. Hope maybe
notice,
he'll use it.
there's a little hole punched in the lid there of the thing. And the idea there is, of course, I put some fuel in there, something that burns very easily. It happens to be methanol. And if you, and a lot of it is in vapor form. So basically, I light the match, and what that causes is it causes the stuff to combust, which causes the temperature in here to rise very rapidly, which causes the gas to expand a lot, or try to expand a lot, right? And of course, if the gas is trying to expand, it's locked except by the hole, right? The hole can let air out, and so what happens is the expanding air shoots out the back, right? So that is, the bottle is exerting a force on the air this way, so the air exerts a force on the bottle this way, right? And this is rocket motion, right? As I just take heated gas, which is trying to expand, I give it only one place to escape, and it's out the back, and then I shoot it out the back, and it pushes me forward. So it's pretty amazing. So what has the greater acceleration here, though? The bottle, which has a pretty good acceleration, or the gas coming out of the back? Right, the gas molecules are very, very small. Very low mass compared to the bottle. So because they're accelerating at a very great rate. Obviously, we do this. It's exactly the same way that we launch the space shuttle or something like that. We've seen the space shuttle launch. It's the same thing. Obviously, I don't use methanol. I use hydrogen and oxygen and do basically the same thing. But it's exactly the same thing. That should illustrate for you, by the way, what are a serious limitation for us as far as space travel is concerned. If I want to accelerate myself, what do I need? I need some gas to throw out the back, right? I need my wrench, or I need gas to throw out the back. Energy is not a problem. We'll talk about what energy is and stuff on Thursday, but energy isn't the problem. The problem is you need stuff to throw out the back. Right? You can have a great energy source all you want, all kinds of energy, but if you have nothing left to throw out the back, then you're screwed. Right? So this is the trouble with trying to travel to the stars. Is I can accelerate for a while, and then I'm going to be done. I mean, the space shuttle, you see it has this ginormous external tanks and stuff that are filled with fuel. It goes through all of that stuff in the course of 10 minutes or something, right? Getting itself to orbit. If I wanted to continue accelerating and go faster and faster and faster and faster to get to the stars in any reasonable period of time, I would have to have way more stuff than that. Of course, the more massive you make your vehicle, the more you need to accelerate it, because the more massive it is. That's our big problem in rocketry, is that the more fuel you have, the more mass you have, the more fuel you need, and so forth, and it's a cyclical thing. And so that's the trouble. If you want to go to the stars, you could shoot yourself off and then just keep whatever velocity you have, but that velocity is likely to be fairly low. For example, the Voyager spacecraft, which has just kind of exited the solar system recently and has been in the news, it's going something like 40,000 or 38,000 miles an hour. That's fast, but not fast if you want to get to a star, right? It's going to take something like 30 or 40,000 more years for it to get to even the closest star, which is not even head-to-head, of course, but so it's going to take it a very long time. If you want to go a lot faster than that, which is what you'd have to do to get to the next nearest star in any reasonable period of time, you have to keep accelerating, and I'm going to run out of stuff to throw. And so we think of solutions like here's my big giant spaceship, and let's have a huge, because empty space isn't really empty. There's an occasional hydrogen atom or something like that floating around. So if I built a big enough collector, I could collect the hydrogen atoms that are out in space and then heat them up and shoot them out the back, right? If I could do that. Unfortunately, this collector, you do calculations how big this collector would have to be in order to do this reasonably. It would have to be like the size of a moon or something like that. I mean, not the kind of technological thing we could build anytime in the near future. So, anyway, that's kind of our big trouble. I'm going to do this one more time. I don't think I should really point it that direction. I'm going to put a little more detail at this time. I don't think it'll do it. All right. I better be safe. I'm going to get sued one of these years. But you guys are going to get burned over here. Gas use a very heavy. Okay, so that's good.